So we're going to start out looking at section 1.1. So it's on functions and graphs. We'll talk about different kinds of numbers, like what do you call an integer, what's a real number, whole number, that kind of stuff. A little bit on coordinates, a little bit on the calculator with graphing. There's a lot of different topics in this section. So here's a diagram of different types of numbers and their names. I'm not going to write down every definition. I will tell you what they are. So if there's anything you don't know, you should probably make a note. We're going to start with the simplest kind of numbers, which is the most inner box. We're going to work our way out. And counting numbers are the simplest. So what do counting numbers start with? What do you think you'd start with when you're counting? Yep. Yep. 1, 2, 3. Exactly. They start at 1. They go up. They don't include any other they don't include negatives. They don't include 0. Don't include fractions or decimals. And what we're really concerned with is doing operations with these numbers. Okay, we're just going to look at basic add, subtract, multiply, and divide. Richard, can you give me a counting number? 5. Okay, so I'm going to do this one here. Okay, we got 5. Michael, can you give me another counting number?
6.
6. Okay. Now I'm going to pick an operation to do between the two of them. Let's start with addition. If I do addition, I'm not concerned about the answer. What I'm concerned about is the answer a counting number. What do you think? Yeah, it would be 11, which is a counting number. So using addition with those two counting numbers is fine. How about if I did, let's do different operation, subtraction. Again, not concerned about the answer. I want to know, is it a counting number or not? No, it's not a counting number because counting numbers start at 1. That's something different. So the reason why we don't just stick with counting numbers, and that's all we use in math, is because you can't do everything with counting numbers. There's something you can't do. So, in fact, you can't even do this. That the answer to 5 minus 5 is not a counting number. So if all you understood was counting numbers, then we're stuck. We'd have to say that 5 minus 5 is undefined. We don't say it's undefined because we invent something to represent the answer to this problem, and that's the number 0. So whole numbers include 0. That's the only difference between whole numbers and counting numbers. Whole numbers include the number 0. But even if we now extend our knowledge to whole numbers, we still can't do everything we need to do. This was a perfect example because 5 minus 6 is not 0, it's not 1, it's not 2, it's not 3. There is no number in the whole number system to represent the answer to this problem. And if you showed that to somebody in like first grade, they'd probably say, well, that's impossible. You don't do that. You can't take away more than you have. Well, you can if you know the kind of numbers to use, and those are called integers. So with integers, that's when we introduce negatives. So now integers include negative numbers, positive numbers, and 0, which is neither negative nor positive. Bless you.
Thank you.
And we're pretty much set with addition, subtraction, and multiplication. All right? You could give me any integer. In fact, I'll ask someone. Xavier, can you give me an integer?
7.1. Does it include decimals?
No.
Okay, so just -7.
-7. Okay, so there's an integer. Lily, can you give me another integer? -2. And I could take those two numbers. I can add them. I could subtract them. Or I could multiply them. And the answer would always be an integer. -7 plus -2, -9. Yep, that's an integer. -7 minus -2, -5. That's an integer. -7 times -2, 14. Yep, 14 is an integer. Where we run into a problem is with the division. If you take -7 and divide by -2, now you get something that doesn't fit in the integer system. So we do one of two things. We either say undefined, it's impossible, we can't do it, or we invent a type of number that allows us to do it. Well, that's where we invent fractions. So rational numbers now include fractions and decimals. They include all the positive fractions and decimals, all the negative fractions and decimals, and the number 0. And for most everyday purposes, rational is probably about as complex of a number as you would need. Like if you're cooking, you might not need 2 cups or 3 cups of flour. You might need something in the middle. You might need 2.5 cups, 2 1/4 cups. If you're buying something at the store, you pay might not be $30 or $31. It might be $30.28. So it's a fraction of the next dollar. That's a rational number. So rational numbers are fractions. The important thing in the fraction is that the top number and the bottom number are both integers. So you can pick like -8 over +5. That's definitely a rational number. What you can't do is something like this. You say, oh, well, that's a fraction. That's rational. No, that's not rational. Because the top and the bottom number in the fraction have to be integers. And we're going to talk about pi in a second. Pi is not an integer. So any number that's an integer in the top, integer in the bottom, you can't have the bottom be 0 because then you divide by 0. Never do that. But that's the idea of rational numbers. They're fractions. And I'm going to talk about the symbol for the rational number system in a little bit. Now, there are still certain operations in math, not addition, subtraction, multiplication, division necessarily, that can result in numbers that don't fit into that system. Can anybody think of a calculation you could do? Simple. That you get an answer that doesn't fit in this system. And I'm not even thinking complex or imaginary. That's not. I'm not going to talk about that today. But that would apply. Yep.
Well, one of the only ones that would do it would have to be square rooting something.
Yep. So if you take a square root of something that's not a perfect square, so I don't mean like the square root of 4, 9, 16. Take like the square root of 6. Well, you're not going to ever get a number that could be written as a fraction. And you might wonder, well, are you sure? Every single square root besides perfect squares, they never could be a fraction? Never. It's impossible. And you can prove it. You can prove that if you have a number that's not a perfect square, like 7, if you take the square root of it, you will never be able to write it as a fraction. It's a very easy proof to do. So because there are things we do in math that don't fit in the rational number system, they call them irrational numbers. So irrational numbers are numbers you cannot write as a fraction. Square root, that's a common one, as long as it's not like the square root of a perfect square. Numbers like pi. Some people think pi is like the fraction 22 over 7. Well, that's 3.14. But 22 over 7 isn't 3.1415926535897993234624638384 I'll stop.
How did you memorize all that?
I've had 17 years to look at it, so if I can't memorize at least a digit or 2 a year, I'm not doing that well.
It was right above you.
Yeah, it's right above me.
Yeah.
So pi is something that is irrational. Now, if you take all the numbers you can write as fractions and the ones you can't, that's called the real number system. And that's pretty much what you study in Algebra 1, and that's what we're going to start off with. So any questions about the names of those different kinds of numbers? And the way I set up the boxes is, it's easy. Think of them as like places, like a smaller place and then getting bigger and bigger. So think of this as like Boston, Massachusetts, New England, United States. If you're in Boston, are you automatically in Massachusetts?
No? Yes.
I mean, yeah. Duh.
Yeah. If you're a counting number, you're automatically a whole number, because a whole number is even bigger. So a whole number includes everything plus more. So think about, like, if you're in Massachusetts, are you automatically in New England?
Yeah.
Yes, but now think of it the other way. If you're in New England, are you automatically in Massachusetts?
No.
No. So if you're an integer, you're not automatically a whole number. But if you're a whole number, you are an integer. That's how the setup works.
So fractions are rational numbers, but if you solve out those fractions and then you can't like write it out, that's when it becomes irrational.
What do you mean solve? Give me a fraction that you would solve out.
I don't know, like, okay, so
Because if you can write it as a fraction, and there's an integer in the top and the bottom, it is rational.
okay, so you can just say irrationals are just all non-rational numbers.
Yes.
Okay.
Yes. Rational and irrational we call mutually exclusive categories. You cannot be in both. You're either rational or you're irrational.
Thank you.
Yep. So a couple different symbols that we use. I think the bottom one, that one makes the most sense. We use this capital looking R with this extra line here. That's the symbol for real numbers. Q with that line is the symbol for the number set that represents rational. Maybe Q for quotient, because rational numbers involve dividing. But the Z for integers, I'm not really sure where that comes from. So those are the symbols we use when we want to talk about these different number sets. The other sets don't have any special letters that I know of. Now, we can also modify them a little bit and do something like this. If I put that symbol down, what do you think I'm referring to now? I'm being a little more specific than just real numbers. Coral?
It's really weird real numbers.
Really weird real numbers. Okay, I guess it depends how you define weird. I don't think they're that weird, but yeah.
Counting numbers?
No, I'm still referring to numbers that might be something like pi plus 2. That would fit into this category. Yeah.
Positive numbers.
Positive
Real numbers.
real numbers, yes. So when you put a plus sign there, it just means you're looking for the positive version of that. So positive real numbers, let's put a negative there. You can make it negative real numbers. And you can do that with any of them. Positive integers, negative integers, things like that. Okay, question on those symbols? So there are 4 basic operations in math that take 2 numbers to make it work. Add, subtract, multiply, and divide. Square root would not be considered a binary operation because you don't plug 2 numbers into a square root. You put 1 number into the root. Okay, but all of these operations take 2 numbers. So we're going to look at a few different properties you may have seen before, like identity, distributive, associative, commutative, those kind of things. I think I'm going to do all the properties with addition, but a lot of them are also true for multiplication. And addition and subtraction are basically the same thing. Because if you think of something like 3 minus 2, it could really be 3 plus negative 2. So if you have a subtraction problem, you can still apply addition properties to it if you rewrite it. So the properties that I'm going to show you, I need 3 variables to do them. And the 3 variables here can be any real numbers. Positives, negatives, fractions, decimals, and zeros. All right, let's start with this one. This one's probably the trickiest one, or one that maybe you haven't seen before, but the idea of closure. Does anybody know what that means? So the simple idea of closure is that you think of a set of numbers, like counting, and then you ask yourself, if I add two numbers, do I always get a counting number? If the answer is yes, then we say that that set is closed. If the answer is no, then it's not. So if I add two counting numbers, will I always get a counting number? Yes. So counting is closed when you do addition. How about multiplication? If I multiply two counting numbers, will I always get a counting number? Yes. Then we say multiplication is closed under the counting numbers. How about subtraction? If I subtract a counting number from another counting number, will I always get a counting number?
No.
No. So then we would say counting is not closed when you do subtraction. So closed means you start with a type of number, you do a calculation, and you end up with the same type of number. If the answer is always yes, then the set is closed. If it's not, then the answer is no. How about with real numbers? If you add real numbers, will you get a real number?
Yeah.
Subtract? So is there a way you could take a real number minus a real number?
I
and
mean,
get
you
an
could do
answer?
like 6 minus 5 is 1, and that would still be a real number.
That's still a real number. So that works. Is there any two numbers you could subtract that you wouldn't get a real number as an answer?
There isn't any, because
There
real
isn't.
numbers go all the way down into negative infinity and positive
Yeah.
infinity.
How about multiplication? If you multiply two real numbers, will you get a real number? Yeah. In division?
Well,
Besides dividing by 0?
there are certain ones of them can be real numbers, and then there are a few others that just don't work out, like pi.
Pi's a real number.
Oh,
Yeah, pi's real. Pi's not rational, but it is real. So are there any real numbers you could divide and you would not get a real number as an answer?
Everything's real numbers.
Everything's a real number. Yeah, everything, unless you're talking about complex. So the answer is no. When you divide two real numbers, you will always get a real number. So we could say even more than that, but the real number system is closed under every operation. Add, subtract, multiply, and divide. There's no way you can take a real number and do something to it, add, subtract, multiply, divide, and not get a real number. You always will. How about commutative? What does that mean specifically for addition?
If you add 1 plus 2 and 2 plus 1, they're the same answer.
So the addition property, addition follows the commutative property, which means you can add two things in a different order, get the same answer. And again, any numbers, doesn't matter what they are, fractions, decimals, it works. How about associative property? Anybody know what that one is? Yeah. Has to do with grouping. Yes. So the idea is grouping, you use parentheses. Order is exactly the same on both sides. But on the left, if you do B plus C first, or on the right, if you do A plus B first, you will get the same thing all the time for addition.
the only way this would change is if there was multiplication or subtraction.
Yeah, if you start mixing in multiplication and subtraction, in the same problem, then yeah, now we have to follow PEMDAS. But if it's just all addition, you can really add it up any way you want. You can do whatever you want first. Identity property, that's something you can do to a number and it doesn't change it. So what would that be for addition? Yeah?
I thought you were talking about for 3 equals x for 30 equals 20x that if you divide by 20 you do it to both sides. I thought that would be meant, not for one number.
So that would be the division property of equality. If you had 2x equals 10 and you divide both sides by 2, you can do that because of the division property of equality. A little different property than, we're not going to talk about that one today, I don't think. But the identity property is something you can do with addition and you get back what you started with. Yep. Add 0. So when we talk about the identity property for addition, it's adding 0. How about multiplication? Is it multiplying by 0? Did that give you back what you started with? It's times 1. So a lot of these properties can be extended to multiplication almost identically. Like you can just change this to a multiplication, a times b, b times a. But with the identity property, you got to be a little careful. It's a little different from multiplication. The inverse property. That's something you can do to a number to basically cancel it out. So what can you do with addition? What can you add to a number that would cancel that number out?
It's a negative of itself.
Yeah, the negative of itself, basically its opposite. So if you add a number and its opposite, you get 0. And the distributive property, this is not something that applies to multiplication. You'd never use distributive property in a situation like that. You would like that, you could. But distributive property is when you multiply something that's on the outside to each term on the inside. And a lot of these properties, again, with the exception of distributive property, you can apply to multiplication as well. And they're all on page 2 in the book that's on screen. Any questions on those properties? Okay, so all of those properties basically involve, they don't involve solving an equation, right? So like division property of equality, that is another property. Addition and subtraction property of equality, that's about solving equations. None of these necessarily have to do with solving an equation. I can just write something like this and do distributive property. It's not even an equation, just a numeric expression. Now we're going to talk about equations. So an equation is now when you put an equal sign between two expressions. These are all different examples of equations. Let's look at the one up here, 5 equals 2. It's an equation. Any thoughts about that one? Yeah.
Correct.
It's not correct.
It's not true.
It's not true. That's a contradiction. So it's an equation that's not true. We call that a contradiction. How about this one? That's an equation that is true. Does anyone know the name for that? An equation that is always true? Yeah? That's an identity. So we have an identity, we have a contradiction. And how about this equation? Is it true or false?
Neither.
Right now, yeah, it's really neither. It could be true if you pick the right number for x.
This one is only true if x is equal to 6.
Right.
Everything else is a contradiction.
There's a condition to make it true. And the condition is x has to equal 6. So we call this a conditional equation. Conditional equation, that's a contradiction. Sorry, it's kind of messy writing this. And this is an identity. But they're all equations. So now let's look at a few properties involving equations, not necessarily some of the ones that were already mentioned, but some other properties. Again, I need 3 letters to do these properties, and I'm going to use A, B, and C. So we'll start with the reflexive property. Reflexive, I almost think of it as like reflective. When something's like a reflection, it's like the same thing you see. So reflexive means that something is always equal to itself. Okay, that's reflexive. How about symmetric? What would that mean when you write an equation? Yeah?
If A equals B, then B equals A.
Yeah, exactly. It lets you rewrite the order, like swap what's on each side. Why would you do that? Well, sometimes people get an answer like this, and they'd rather write it with the variable on the left. X equals 3. And how about transitive? Anybody know that one? Yeah, Joe?
It's like if A equals B and B equals C and A equals C.
Yep. When you have like a chain of things, it can be as little as 3 things. It can be as many as hundreds of things. But if A equals B and B equals C, then that means A must be equal to C. Okay. Questions on those? So let's look at an example. We could do this really 2 different ways, where I give you a problem. And what I would have you do with this is either I give you the steps for how to solve it, and you tell me the name of the property that I used at each step, or the other way would I give you the name of the property, and you tell me how to do that step in the problem. Let's do it where I'll give you the name of the property, and you tell me how to do that step. Okay. So first step in that problem is distributive property. And Jack, what side does the distributive property apply to?
The left side.
Yep, applies to the left side. And can you tell, Sophia, can you tell me, you don't have to simplify, but how I do the distributive property on the left?
Multiply 2 times x.
So multiply 2 times x,
Add 2 times 3.
and then add 2 times 3. That's all you have to do for the distributive property. Now, kind of the next step, which we didn't really mention this, but we simplify. That's where you could actually do 2 times 3 out and write the answer. Yep.
The answer of that's 6.
Yep, 2 times 3 gives me 6. And now we know those are the same thing, but before I show you the property, does anybody know what property allows me to make the left side look exactly like the right? Yeah. So symmetric would be if I took 2x plus 6 and put it here, and I put 6 plus 2x over here. So they still wouldn't look exactly the same, they would just switch sides. Yep. The commutative property. Yep. So with the commutative property, you can apply it to either side. I'm going to do it on the left. 6 plus 2x equals 6 plus 2x. And that's basically a proof. It's an algebraic proof of why the left side equals the right, with those 3 reasons. Any questions on that? Okay, coordinate system. We're going to talk first, not even about a 2D coordinate system, just 1D, so like a number line. I think I showed it already, but what do you call the spot right where the numbers start? If they start at 0, you call this the origin? Yep, the origin. On a one-dimensional number line, it's pretty standard that positive numbers go right, negative numbers go left. If your number line is vertical, positive would be up. So with a number line, that gives us placement of numbers. Now we can say like that this number is to the left of that number. Well, if it's to the left of it, that means something about it. And when we start describing relationships between 2 numbers on a number line, we can use 4 different symbols. Those 4 symbols have a name. Does anybody know the name of the group of the 4 symbols that allow you to describe the relationship between 2 numbers? Yeah.
2 guesses: numerals or quadrants?
We're going to talk about quadrants when we get into a 2D coordinate system, which is probably the next slide or 2. I think, but not the one I'm thinking of. Yeah. Inequalities. Okay, so there's your 4 inequality symbols. And if you already know them, you don't need to write them. But you will have to know them and know how to use them to graph something like x is less than 2 on a number line. So you'll have to know what they mean. Okay, so how do we graph on a number line? Well, we have to do two things. If you wanted to graph something like this, on a number line, can someone tell me what the first step is? 2 steps. What the first step would be?
The first step would be to put a point that's filled in over 2.
Right, so you're going to put some kind of symbol on the number 2. I'm going to show you 2 ways to do it. One way is to fill in a circle. Yep. So you put a closed circle on the number 2, or another symbol, which I'll show you. And then once you put the closed circle on the number 2, what do you have to do?
You put a continuous line in the direction it says.
Right, so we're going to draw like a ray in one direction.
Right.
Yeah. So we'll shade in the number line. Yeah. So this is one set of options you can use for the symbol, probably the one you're most familiar with, open circle and closed circle. Open circle is always used with the greater than and less than. Closed circle would be used when you have the equal to. Now, if they give me something like that, this is where I kind of use one of the properties we talked about a little bit to rewrite it. And when I write inequalities, I generally don't like to put the variable on the right. I like to have it on the left, put the 2 on the right, but I just have to be careful with what I put in the middle. If I rewrite it that way, what symbol would go in the middle? I mean, we know it's something with an equal to, because the original problem had an equal to. But what would it be, a less than or equal to, or a greater than or equal to? Yep.
Greater than or equal to.
Yeah.
And then the reflexive property, I think.
So we want to make sure, if you rewrite it, that when you use an inequality, it's always pointing at whatever it was originally. And the reason that I rewrite it with the variable on the left is because if you put the letter on the left, this symbol tells you which way you're going to shade. To the right. If you don't rewrite it, and you keep the variable on this side, then this symbol is telling you the opposite way to shade. So that's why I think it's simpler to just always put the X on the left. You'd get credit either way if you wrote those as answers to a problem, as long as the 2 was the correct answer. Okay. So open circle or closed circle on the number 2. Yeah, Zach? Yes, closed circle. I should number this though. So closed circle. And James, which way am I going to shade? Yeah, we're going to shade to the right. So you can shade right on the number line. When you do this on Edge Elastic, it's going to be on the computer. You can kind of click where you want to put your dot, and then you can choose whether you shade right or left. It's pretty simple. I'll show you. But that's how you'll do it on the computer on a test. All right, let's try this one. Again, I'd prefer to write it the way that's on the right, but the way that's on the left is same thing. You're also not going to have to number your number line. It's already going to be numbered for you on Edge Elastic. Put some numbers in. Okay, what kind of symbol am I going to put on 3 this time? Yeah, Ryan? Open circle. Okay. And how about, Anna, which way am I going to shade?
You're gonna shade to the right, the left.
Yeah, we want to shade to the left. So if you look at this one where the variable is on the side, it's pointing towards the Y. So we're going to shade all numbers that are less than 3, which means to the left. So we shade this way. Okay. Questions on it? All right, so open circle and closed circle is one way to do it. What you're going to see in our book in place of that is bracket and parenthesis, but it means the same thing. So our book is going to use a bracket for in place of a filled-in circle. So here's how this one would look if you use a bracket. You're going to put a bracket on 2 because it would be like the filled-in circle. But you have to pick the right bracket. The bracket has to face the way you're going to shade. So if I'm shading to the right, my bracket would look like this. So it's very similar, except it uses a bracket. So the reason you have to know that notation is because I might give you a picture like this on a test and ask you, what does this picture mean? And then you tell me x is greater than or equal to 2. When you're drawing it by hand or on the computer, you can stick with the open and closed circle if you want. Okay, but you do need to know what that symbol means. So bracket can be used in place of the closed circle. Parenthesis can be used in place of the open circle. Same deal. When you put the parenthesis, you got to put it the way you're going to shade. So you got to think about it a little bit. We know that on this one we shaded left. So parenthesis, facing left. And shade. Okay, just a different way to do it. Probably not as common as open and closed circle, but that's what it is. Any questions on that? All right. Another shading problem, but this is a little different. This is a problem that you would read and you'd say the word and. When I read it, I start in the middle and I say x is greater than or equal to 2 and x is less than or equal to 9. Does anyone know what that's called? An inequality with the word and?
An and inequality?
Okay, yeah, it's an inequality with and. There's another word for it. It begins with a C.
Combination.
Not combination.
Combination inequality?
No, not combination inequality. It's a. Does anyone know what the word and is? Like in English? And is a conjunction. Yes. So this is a conjunction. Conjunctions, you can write them kind of squished together. When you have the opposite of a conjunction, a disjunction, that's the word or, you can't really compress an or statement. You have to write something or something. But an and, you can take these two statements and squeeze them together as that. And if you look at it, you can kind of see where they come from. X is greater than or equal to 2 is right there. X is greater than or equal to 2. And x is less than or equal to 9. X is less than or equal to 9. You can write it either way. I'm probably going to write conjunctions shorter rather than writing them out. But is there any question on how you take a conjunction and write it out? Or take something written out and compress it? It's Algebra 1 stuff, but I just kind of want to make sure people remember. Okay, so let's try graphing that. We can use either circles or the brackets in parentheses, but don't mix them. If we're going to use circles, let's use all circles. Okay, so let's try it with circles. Need some numbers on here. And if I want to graph that, what would be the first thing I would do? Yep.
You'd put a filled-in point at 2 and 9.
Okay, so we need a closed circle on 2 because of that symbol. We're going to need a closed circle on 9 because of that symbol.
9's, yeah.
And now we always have to do the shading. Where do we shade?
Inside.
Yeah, between them. Everything that's greater than or equal to 2, but less than or equal to 9. So with a conjunction, you usually end up shading between. Any questions on that? So I think that mostly covers number lines and like one-dimensional. I think there's one more thing we look at, and that's the distance between two numbers. Yeah. So absolute value is what I basically just said. It measures a distance, okay, between usually a number and a certain spot on the number line. Does anybody know where we usually measure the distance from?
0.
0. Yep. So it's the distance from 0. So that's a very geometric way to think of it, a visual way to think of it. How far away is it from a certain spot? But let's think of it a little different way. There's really two cases when you have absolute value. If I gave you a positive number and said, find the absolute value, what would you do to the number? Yeah?
You would leave that number alone.
You'd leave that number alone. If I gave you a positive number, all you'd have to do is give me back the same number. But that only works if I give you a number that's greater than or equal to 0. Now, what if I gave you a number that was less than 0? What would you do to that number to find the absolute value if it was less than 0? Yeah?
Wouldn't you add the negative?
Yeah, pretty much. I'm just looking for a different way to say it, but yeah. Make it positive, which means you're really taking the what of the number. You're making the number its, yeah? Yeah, it's inverse. You're making it the opposite. Yeah. So if you have a number that you know is less than 0 and you want to take its absolute value, you need to take the opposite of the original number. So how would that work? Let's say you plug in a -3 right here. If you want to take the absolute value of -3, you need to take its opposite. The opposite of -3. That's how you'd write it. Opposite of -3, which would be +3. So that's just a different way to think about absolute value, breaking it into two cases. Don't do anything to it if it's positive. Take the opposite of it if it's negative. All right, so do a real quick couple examples. Absolute value of 6,
6.
And -3,
3.
3. So just measuring how far away something is from 0 on a number line. So if I was programming this like on a computer, this is how I would have to think of it. If the computer doesn't understand, like I couldn't just tell the computer find the distance. It might not know what distance means. But I could easily tell it, just give me back the same number the person typed in, or give me the opposite of the number the person typed in, depending on one of two conditions. So it's a real concrete way to think about absolute value. And if you want to find the distance between two just numbers on a number line, you subtract them and take their absolute value. That's the formula to find the distance between two values on a number line. Technically, you could do b minus a, wouldn't really matter, because you're taking the absolute value.
Yeah, whenever you're doing the absolute value, the symbol on the inside doesn't matter. You can have it in either way.
When you're doing subtraction, yeah.
Addition and subtraction.
Addition or subtraction, because you're going to take the absolute value, so it's going to come out positive either way. Okay, so let's say I want to find the distance between -2 and -9. Think of -2 as A. Think of -9 as B. And just plug them in to the formula.
7.
So A is -2. B is -9, and I'm going to do this out just to make sure people remember something. There's A, there's B, and subtract B. But what happens here when you subtract a negative?
It becomes a positive.
It becomes a positive. So this is really -2 plus 9, which is 7. And then the absolute value of 7 is 7.
The way that Mr. Curtis said that if there's a negative and a negative in parentheses, you can just put a line. You would just connect those pure two minuses to make the plus.
Yeah, yep. As long as you remember when you subtract a negative, you get a positive. However you remember it, it's good with me. Okay, so two-dimensional coordinate system. I heard a couple words earlier that would apply to that. Can somebody tell me anything about two-dimensional coordinate system? Anything you know? Yeah?
X-axis goes left and right, and the Y goes up and down.
Yep, we usually call the two lines the axes. We don't call them number lines. An x-axis is horizontal, y is vertical. Good. What else? Yep.
The origin is at 0, 0.
Yep, we have a thing called a coordinate, which gives you a location. And there is one coordinate with a special name, and that's the origin, 0, 0.
Quadrants.
What are quadrants? There's 4 of them. Yeah, quad meaning 4. What is a quadrant, though?
Well, like the top right quadrant usually is all positive numbers.
Okay, so we have a certain directions that are positive and negative, but how are quadrants formed? Like, what are they? Yeah?
The 0, 0 is at the center of the 4 quadrants. That's the meeting point of the x and the y-axis.
True, yeah.
The first one is normally the top right, the second's the left one, and the third's the bottom left, and then fourth is the last.
Bottom right. Yeah, so quadrants do have numbers to them. Yeah.
You did say that it's when you cross over an axis.
Right, so quadrants are defined by axes. They're the regions, they're the 4 regions that are created in the coordinate plane by drawing a vertical and a horizontal axis. Yeah. And I think we pretty much set up. So horizontal axis is x, vertical is y. Positive direction is right and up. Negative direction, left and down. We said origin, that's where the 2 axes cross. And I think we said the name of this, but what do you call the thing that gives you a location?
Distance.
Point.
Coordinate.
You can call it a coordinate or a point. There's also one other name. Actually, 2 words. You may know another name. It's a specific name for a coordinate that's two-dimensional.
Vertex.
No, not vertex. Because I can have a name of a coordinate that's 3D, or I can have a coordinate that's 2D.
Corner.
What is it?
Like corner, because everything has a corner. Like from 2D to like 3D. Like a box can have a corner, and then also like a chord box can have a corner.
It's not corner, no. It's another term that means specifically a two-dimensional coordinate, and it's 2 words. Starts with an O. That's an ordered pair. So a two-dimensional coordinate is an ordered pair. You can have an ordered triple. That'd be a 3-dimensional coordinate. A coordinate is kind of the generic term for a location in general. Pair means 2. X value first, Y value always second. Any questions on the coordinate? This is called a coordinate plane. and it is two-dimensional. Okay, so graphing calculator, let me just see, I think we're almost, yeah. Okay, so zooming on the calculator. So that is a big thing we're going to do all year. And we may have to zoom in or out depending on the graph that we're drawing. Let me graph something and just show you what can happen. I'm going to go to my calculator. I'm going to turn it on. So you can press on. Now, if you're at a screen other than the main screen, you can always press the second button, which is in the upper left, and then mode, which is quit, and that should take you out of anything you're in, so now you're back at the main screen. If there's things on the screen that you don't want there, you can press the clear button, and that will get rid of them. So hopefully everybody's at a screen that looks like that. Anybody need help getting to that screen? Yeah. And did you try second quit?
Yeah,
Yeah, it still says test mode.
Oh, at the top? That's okay. Yeah, it'll say that. So you can just press second quit. And then mode. Yeah, so that's the screen you want to be at. Yeah, it'll say test mode. All right, now I'm going to do something. You can just watch me do this. I'm going to type in x squared plus 10. What's the name or what kind of shape is that graph going to be? X squared plus 10.
The graph would be a U-shaped, and it would be facing upwards, and it would have its crossing of the x-axis, or no, the y-axis would be at 10, or
Yep.
0, 10.
Yep, have a y-intercept of 10, and there's a specific name I'm thinking of. It is a U shape.
Hyperbola.
Not a hyperbola, but it's
Parabola.
kind of like that one, parabola.
Correct.
Now, I'm going to hit zoom 6. I'm just going to graph and watch what happens when I get on the screen. When that little yellow circle is spinning in the upper right, I don't know if you saw it, it means it's doing something. When it's done, you should see something. Now, I don't see anything because my graph is off the screen. So what I need to do is adjust my window so it fits on the screen. So what I need you to do is press the button in the upper left that says y equals. And the way that you get the x variable, it's go one row over and one row down from the top left. It has an x comma t comma theta. You press x. One way to get an exponent is to press the x squared button. It's the 5th button down on the left-hand side.
What did you do like the first number?
I press this button right next to alpha.
Out.
And then I'm going to press x squared. And then I'm just going to type plus 10. Now, anytime you graph something, before you go to graph, we're always going to set our window, or we're going to set the zoom. Okay, we do one of those two things. If you do zoom and you do 6, you will, if you've done it correctly, you will not see anything on the screen. Because what zoom 6 does, I'll show you right now. If you press window, you can see the smallest x value and the biggest, and the smallest y value and the biggest. We're just focusing on those 4 numbers. Don't worry about anything else. This parabola has been shifted up 10 units. That's what the plus 10 is. So what we can do is if I want to see higher, because the parabola is up here, which one of those values do you think I need to adjust?
The y values,
Which one?
the y min and the y max.
So y min is going to let you see lower.
So the y max you would want to make bigger.
So the y max we want to make bigger so we can see higher. There's no really right or wrong answer to see it. You could try 20. Hit graph. And now you'll see a parabola. Now, if you set it too high, it's not going to look good. Like if you set it to like 5,000, what that's going to do is it's going to zoom you so far out that it's not even going to look like a parabola anymore. It's probably going to look almost like a straight line. That's going to be way too big. Not quite a straight line, but it looks pretty close. If I zoomed out even more, it would be. So we got to get a picture. Like if somebody looked at that and I said, what is that a picture of? Like in my next class, and I just showed them that, they probably have no idea that that's a parabola. It doesn't really look like one. So you find a good window, 20, 30. It just takes practice to kind of find a window that makes the graph look like what it should be. Can anybody not get a parabola on the screen?
I have no idea.
Not sure? Did you type in your equation under y equals?
Yes.
Okay. So once you type in your equation, press zoom. We'll start over with zoom 6.
I press zoom 6.
Yep.
Yeah.
And zoom 6 will bring it back to what we started with. Now, another thing you can try if you're not sure what numbers to put in here, you can try just zooming out. Doesn't always work, but I'll show you how to zoom out. You can press the zoom button, and instead of pressing 6, you can press 3. If you press 3, it doesn't zoom out right away. It gives you this little blinking cursor. Wherever you put that cursor, that's where it's going to zoom out from. I want to zoom out right from the middle. So I'm going to zoom out right from the origin. So if your cursor is blinking and it's at the origin, just hit enter. And it's going to zoom me out. Yeah, it zoomed out a little far. It's looking kind of skinny. It's also going to give you weird numbers now in the window. If you go to the window, see how sometimes it puts these kind of weird decimals in here? It's fine, but I think negative 40 to 40 is probably a little too much for this graph. But I can tell it's a problem. So it's okay. It's kind of hard to tell where it crosses the y-axis. When I look at those tick marks, that's really hard for me to count because we're so far zoomed out. I'd probably have zoomed in a little more. Good. So any questions on how I zoomed in and out? Yeah.
For assignments, are you going to need us to have like a picture or like a representation of what we got on our graphing calculator?
So there'll be some questions in the book that say, set your calculator to a window of, and then it'll give you a value. You can just do it on the calculator. There's nothing to really show on paper.
Oh.
So there are some questions there's nothing to show. Yep.
I'm just saying it has an error.
Has an error?
That's the graph.
All right, let's take a look. All right, show me what you typed in. All right, let's go up to the arrow and hit enter. One of your scatter plots was turned on. Hit it. Yeah, just hit it. Right, set your window. So what happened on Joe's calculator? The last person who used it, they had one of the scatter plots turned on. And the way I could tell that is plot 1 up at the top was highlighted in black, and that was messing him up. So if that ever happens, I would help you with that on a test because that's something you don't know about yet. But to turn off a scatter plot, I told him just press the up arrow. Now it's highlighted. Press enter, and now it's turned off. But that's something you wouldn't have known. So I would help you with that. So anyone else have a question on that? Yeah.
How do you bring x squared plus 10?
X squared plus 10. So you press the X button, which is right next to alpha. Then the squared button, which is on the left-hand side, 5 buttons down. And then you just press plus 10. Okay, so it's giving you a different letter. All right, so If you're not getting an X, it's because your calculator is in a different mode. So again, you wouldn't know this either. I'd help you fix it. So press mode, and yours is on parametric. It says normal, but does it say parametric down here? Yeah. So go down to where it says function. And now function should be highlighted and hit enter. We're leaving it on function for like 6 months, so that should never change again. Excuse me. Okay. Anybody else?
I think I might need some help with this.
Yep. What's going on?
Well, when I try to set the window for the minimum and the maximum, it just keeps giving me an error.
Gives you an error? Let me see what you typed in. So you can't have the minimum the same size as the maximum.
Okay.
You have to have them different. You also can't set the minimum bigger than the maximum. That wouldn't make sense. The minimum has to be smaller, the maximum has to be bigger.
So, like, a negative number would work, right?
Yes. One thing to be careful about is when you type in a negative, there are 2 symbols on the calculator that look like a dash. There's this one, and there's that one. They're not the same symbol. You can actually see the difference if I make it a little bigger. One of those is a negative. One of them is a subtraction symbol.
Oh.
So you cannot use them interchangeably. Yeah.
Okay, we got water.
Yeah. The negative symbol is down by the decimal. So if you want to type -3, the subtraction sign is by the multiplication and addition sign. So if you type the wrong one, it won't work. Yeah.
Are you only able to graph 9 lines, or are you able to
I think 9 is the maximum. Maybe 10 if there's a Y0. But yeah, you can only do up to 10. We never have to do more than 3 at a time. Okay, so we can try that. Well, when they want you to set a window, they'll give you 4 numbers. These 4 numbers mean the following. That's X min. That's X max. The first 2 are the X's. The next 2 are the Y's. Yeah. Yep, just sign out. Y min, Y max. So when they want you to set a window on the calculator, that's how they'll tell you the 4 numbers. Usually just like that. And how would you do it? Well, press window. X min, -20. The negative is below the 3. -20. X max, +20. Don't worry with the other ones too. It's not important. Y min, -20. Y max, +20. And if that was the question on the homework, that's all you would do. You don't have to show anything on paper for that question. It's just practicing zooming on the calculator. I think that confuses some people because they're like, wait, what do I show? Nothing. I'll know if you know how to zoom because on the test, I might give you 4 different pictures to look at and say, if you graphed this equation and you use this window, which one of the following 4 pictures would it look like? So if you know how to do it on the calculator, you'll get the right picture. But that's something on the day of the test I wouldn't tell you how to do. I need to know if you know how to set your window.
So what does the zoom do?
Well, zoom kind of zooms you in and out, but it picks values for you. Sometimes it picks good values, sometimes it doesn't.
Huh.
Window, I can kind of control exactly what I want to do. Like if I wanted to only look at quadrant 1 in a graph, I could set my minimums to 0. And now I could focus on just quadrant 1. I'm not looking at quadrants 2, 3, or 4.
So that would be for like a scatter plot.
Yep. If you were going to do a scatter plot, that's how you would want to set your minimums, exactly. You can change the number of tick marks you see on the screen. Like you can see how many tick marks I have there. I never change it. But if I wanted to put like a lot more tick marks, I could do that. And now you can see how one axis has a lot more than the other. Why would you change the tick marks? I don't know. I never do.
Oh, I would know the reason. Then you probably would. If you have more numbers for one axis, but you have less numbers for the other axis, you can use that.
Yeah, you can change it. You probably won't need to ever in this class, but you could if you want. All right. So last two things. So the distance formula and midpoint formula. So we talked about how to find the distance between 2 points on a number line. All we have to do is do the difference and take the absolute value. Well, in 2D, it's a little more complicated. That's your formula. But does anybody know where this formula really comes from? When you're finding the distance between... Yep, it's the Pythagorean theorem. Because if you have 2 points and you want to know the distance between them, you don't actually find it directly. What you do is you figure out how far apart the 2 points are this way. Yep, that's that. And then you figure out how far apart the 2 points are this way. That's that. And then when you square them, add them up and take the square root. That's the Pythagorean theorem. So what you're really doing is finding the length of two sides and then doing the Pythagorean theorem to get the hypotenuse. That's the distance formula. Okay, let's try one of those. So if I was going to set that up, what would my x1 value be?
Yeah. 6 minus 4.
So we could do that as 1.
Can't you also do it? Actually, no, you have to use the first x, right?
You could have done 1 or 5. It wouldn't make a difference because you're squaring it. So as long as you pick either 1 or 5 for x1, you're okay. So we picked 1. So what does that mean x2 is?
That's right.
5. Why 1?
4.
4. And why 2? 6. So then when we simplify it, we get negative 4 squared. And 4 minus 6 is squared. 4. So you get the square root of 20. But whenever we get a square root that can be simplified, you always simplify it. And what does square root of 20 simplify to?
Two square root of 5.
Yep. So that's something from algebra you do need to know, how to simplify square roots.
Did you go over that at some point?
Yeah. I mean, the quick way, we can go over it more, but you break 20 up. The way I do it is 4 times 5 is 20. I try to break 20 up into 2 numbers, and one of them has to be something I can take the square root of.
Okay.
And that's 2 square roots of 5. There's other ways to do it. That's how I do it. Okay. And the last formula is not finding how far apart 2 points are, but finding where the middle of 2 points are. And if you look at what you're doing, you're adding 2 things together and you're dividing by 2. What's that called? Yeah. It's really the average. That's all the midpoint is. You average your x's and then average your y's, and that gives you the spot that's right in the middle. So let's find the midpoint of those 2 coordinates, and that's the last one. What's x1 in this case?
-4.
Negative.
-1.
So we're going to do it for these, not the previous one. We're going to do it for those coordinates. What's x1?
-1.
Oh, it's like plug it in.
Yeah, you might be giving me the final answer.
Yeah, it was. It's -5.
-5.
Oh.
And what's x2? Just in case people aren't sure how we got there. 3. And what's y1?
7. Or 2.
Yeah, 2. And what's y2? 7. And then when you add these up, -5 plus 3 is -2 divided by 2. There's your -1. And what's your y value? Fraction or decimal?
Okay, then 3. Not sorry, then 3 and 4.5.
4.5 or 9/2? Either way. Okay, so there's a lot of different topics in that section. Hopefully most of it was review. If you're concerned about any of them or you're not sure, going too fast, we do slow down, but we got to get through some of this basic stuff first.
Just leave the calculator.
So when you are done with the calculator, it has a number. Make sure you put it back in the right number slot, but you can put them back. Okay, and homework tonight is on page 11, and you can find that on Schoology, the PDF.